Hello everyone, welcome back to my channel. So today we are going to discuss principle of X-ray production, how these X-rays are produced and what is the basic principle behind these X-ray production. So let us discuss it briefly here. So we can see that there is a filament here, okay? So this filament is heated up. So when this filament is heated up, due to thermoionic emission, electrons are emitted out from this filament. But what we want is, in order to produce X-rays, we want these X-rays to accelerate towards this target material. So in order to accelerate these electrons towards the target material, we provide a high voltage between this target material and this filament, okay? So the positive terminal of the battery is connected to the target material. So the electrons can accelerate towards this target material. Electrons are negatively charged, so they will be accelerated towards this target material, and as a result of which, when these electrons interact with the atoms of the target material, X-rays are produced. Okay, so this is the brief introduction to the X-ray production. We are going to discuss this in detail in the upcoming slides. Okay. So what are the contents? These are the contents which we are going to discuss in this video. First is the introduction, a basic introduction of X-rays. What is the basic idea behind these X-rays? We are going to discuss it in this section. Secondly, we are going to discuss the history of X-ray invention, how the X-rays were invented, who invented X-rays, and a basic story behind these discovery. Okay, so it become more interesting for us to discuss these X-rays. Okay. And thirdly, we are going to discuss the atomic structure. So why we are going to discuss atomic structure? It is because X-rays mainly interact with the atomic structure of the particular target material. So we should know the basic idea behind the atomic structure. Next, we are going to discuss types of X-ray production, the different ways from which this X-rays are produced. We are going to discuss it in this section. So now basically there are three ways which are characteristic radiation, means the characteristic X-ray radiation. How these characteristic X-ray radiations are produced, we are going to discuss it in this section. And secondly, we are going to discuss the Bremsstrahlung X-ray radiation, which are the result of Bremsstrahlung scattering. So these are the contents we are going to discuss in this video. Okay. Now the introduction part. What are X-rays? X-rays are basically a part of electromagnetic radiation spectrum. Okay, so the wavelength of X-rays varies from 0.01 nanometer to 10 nanometers. Okay, how these X-rays are produced? When a beam of accelerated electrons interact with the atom of target materials, X-rays are produced. So this part we have already discussed it. Okay, so when these electrons are bombarded on a target material, X-rays are produced. Okay. Now, whatever energy carried away by this incident electron, 99% of it is converted into the heat energy, and very less energy, which is 0.2% of the energy of the incident electron, is converted to the energy of the X-ray photon. Okay. Now, when X-ray photons interact with patient, there are number of possible interaction between X-rays and atoms of mediums. Okay, so this interaction mainly depends upon the energy of the photon, okay, the energy of the emitted photon, and what is the characteristic of the absorbing material. How much amount of energy can be absorbed by this material? It depends on the property of the material. Okay. Now next one is, these interactions are very important. We should know the interactions of this electrons with the material should be well known by us. Why? Because it is very important in diagnostic radiology for image formation as well as radiation protection to patient as well as worker. So in order to protect the patients and the worker which are working in these radiations, we should know the physics behind these interactions very carefully. Okay. Now let us discuss the brief history behind the discovery of X-rays. So how these X-rays were invented? So on 8th November 1895, a German physicist, Sir W.C. Röntgen. So what happened to W.C. Röntgen that day? He was actually working on a cathode ray tube experiment. Okay. So that day what happened is, when he was working on this experiment, he did some variations in his experimental setup, and accidentally what he saw that there is a material which is barium palatino-cyanide screen, which is shining, or we can say there is some fluorescence on this material. So initially what he thought was there is some leakage in his experimental setup. So he covered the entire setup, but still the fluorescence was there on that screen. So he was not able to figure it out. Okay. So for few days he did not tell anyone about this in his university, because he was a professor there. So people will make fun of him that he had done such a blunder in his experiment that a leakage is occurring in the experimental setup. Okay. But when he during his investigation of why is this material is shining, what he did is he put a book between those rays. He found out that the rays passes through the book also. Then he put his hand over these rays, then the rays passes through his his hand also. Okay. So he noticed that these are some rays which can pass through almost all matter particles, almost all materials. Okay. So since he did not know anything about these rays, he named them X-rays. So invention of these X-ray, discovery of these X-ray was actually an accidental discovery. Sir W.C. Röntgen was not willing to discover X-rays. He was working on some other experiment, and X-rays were actually accidentally discovered. Okay. So since he did not know anything about these rays, so he named them X-rays. We do this in mathematics, that we don't know anything about some quantity, so we assume it as X. So these rays were assumed to be X-rays, and from then onwards these rays were called X-rays. Okay. So this is the story behind the invention of X-rays. Now let us discuss the atomic structure. Okay. So what is the atomic structure? Today, whatever concept we are considering for the atomic structure is taken from the Bohr's model. Bohr gave his model for the atomic structure. According to his model, he gave 3 statements. What are the 3 statements? First statement was electrons revolve around nucleus in a circular orbit, and the centripetal force required for that circular motion will be provided by the Coulomb force between electrons and protons. Secondly, he said that electrons will orbit in a particular orbit where its momentum will be the integral multiple of Planck's constant h bar. Okay. His third statement was, he said that whenever there is a transition of electron from a higher energy level to a lower energy level, or a lower energy level to a higher energy level, whatever it will be, there is a respective photon emitted. And what will be the energy of that photon? The energy of that photon will be equal to the difference of both the energy levels. Okay. Now, there are different principal quantum numbers assigned to different energy levels. For example, for K shell it is 1, for L shell it is 2, for M shell it is 3, and so on and so forth. Okay. Now the number of electrons which can be filled in a particular orbit is filled according to the principle 2n square. Okay, so for k n is 1. Okay, so according to 2n square, how many electrons can be filled in k shell? 2 electrons. Okay, because n is equal, when we put n is equal to 1 in this formula, we'll get 2. Okay, so 2 electrons can be filled in k shell. Similarly, for L shell, how many electrons can be filled? For L shell, the principal quantum number is n is equal to 2. So 2 square is 4, 4 into 2 is 8. So this is how electrons are filled in a particular orbit, which is according to their principal quantum number. Okay, now the entire positive charge of the atom resides in the nucleus. Okay, so protons, so what are the particles which are in nucleus? Protons and neutrons reside in the nucleus, and the electrons revolve around the nucleus in a circular orbit. Okay, now different materials will have different number of protons and electrons in their atom. Okay, but if there is a same material, then the number of electrons and protons in all the atoms of that given material will be same. Okay, so this is the basic concept behind the atomic structure. Furthermore, we are going to discuss in detail how X-rays were produced, and Brahms-Strahling scattering also we are going to discuss, and also the characteristic scattering. Okay, so these are the two kinds of X-rays we are going to discuss in detail in the upcoming video. So in order to resolve all your doubts regarding X-ray production, you should watch the entire video, and thank you.